Hi guys, welcome to my channel. This is Cliptronics with a new project around microcontroller and electronics for beginners. This means I will try to explain the best I can and give you as much information as possible on my project. This is a pledge I make because sometimes I've watched a lot of videos before doing mine, and I sometimes quite baffled because I try to do the project, so I try to understand the project, and they're not always well explained. Not everything is explained thoroughly. I'll try to be as thorough possible. If I miss things, if you don't understand, please leave a comment in the comment section. So this is a multi-part series. I don't know exactly how many parts yet, but basically this is something that revolves around a fish tank. Now the first part of the project is the essential part, is because all fish, gotta eat. So this is a fish feeder. It's really a big tongue twister. Because eventually you need to go on holidays and you need to feed your fish while you're gone. So I found this Instructable by a guy named Shane. I'll put the link in the description if you want to see the original video and Instructable. I probably post an Instructable of my project as well when I have the time. So can people, because I find Instructable also a nice way to, to share the project. You don't have to watch the video, you can just read it, take your time. So I will do one as well. There you go. So I just built this project around simple recoup stuff. So basically this is a plastic box, so like a little plastic drawer. This is a little container for sampling, medical sample. Don't worry, it's clean. This is a servo, also a recoup servo. Now the other parts are and the battery, the lithium battery is recoup. The other parts are bought new, of course, over our friends in China. Now you've got an Arduino Nano, which is basically like an Uno, except smaller. A little step up here, because you need to step up those 3.7 to 4.2 volts from that lithium battery. And you've got a little charging board, so you can plug it into a solar panel or a power bank to make sure that your project is always powered. Now I will demonstrate, so a little explanation before. So basically you've got your fish feed here, and you plug two holes here. Now when the time comes, so that's the interval, you'll have to decide whenever you want to feed your fish, I mean. It's going to turn, and the servo is going to turn the little box 180 degrees and then back again. And so the feed is going to go through the hole. So let me just demonstrate. There you go. A little link sketch to tell me that everything is fine. And it's about 5 seconds. Yeah, there you go. There you go. Now you can, I'm going to turn it off quickly. Now you can regulate yourself how much food you need to give them and what's the interval by, doing bigger holes, smaller holes, 1 holes, 2 holes, whatever. You need to figure it out for yourself, I guess. So a little later on I'm going to go through the code, the Arduino code for that project, and but let me tell you first a little bit about what I want to do with it. So I want to add some monitoring to the project. I'm going to add, for the next video, this little sensor and probably a LCD screen, so that we can monitor the temperature and we can see when the feeder is on. Right guys, before we have a look at the code, let's have a quick look at the schematic. So first off, we've got a battery pack here, two 18650 in parallel. Now in the project I showed you, it only had one. I think two is better. You add some capacity to your project, it's fine. I mean, these batteries should last long. This is not a great power draw, but to be on the safe side, you can always put two in parallel, but one will be fine, I think. Now, these batteries, of course, will be charged by a TP4056, which will be charged directly through a solar panel, or it could be a power bank. It's up to you. And don't forget to put your blocking diode if you're putting a solar. Ideally, you want, let's say, about 6 volts, maybe on your solar panel. You know, between 5.5 to 6 volts, which the TP4056 will handle very well, and about, I would say, a minimum of 200 milliamp of current at full power for those solar panels. So the battery then goes out to a stepper. So a DC to DC converter, a boost converter, goes up, stepped up to 5 volts, goes into the VIN and the ground of the Arduino, and the Arduino itself is connected to the servo via the 5 volt rail and the ground rail, and of course the digital pin, which is an output pin to the servo. Now let's have a look at the code. So first off, we start by including the servo library. So include servo.h. Then we create the myServo object. After that, we declare 4 variables. The first one is the position of the servo, the POS, which we set at 0. The second variables is the fish feeder variables. It can be anything you want. It's the interval in between each feeding. So in my example, it's 5,000 milliseconds, but you know, you've got to count the number of interval you want. That all depends on you. So convert it to milliseconds. End time is the addition of those two. The now variable, which is where you store the milliseconds that has passed since the beginning of the program. So these are the 4 variables. Now, in the setup, we start off with a little blink sketch to see that the microcontroller is working fine. Then after the blink, we will start the serial monitor. Then we will attach the servo on pin 9, which is an output pin because it's a digital pin, so you don't have to define it here in the pin mode. And then we tell the servo not to do anything. So it's 0. Now I've added here as you know, something that you can decide not to implement. A little delay and the feed time function we'll see later, which is the actual function that executes the rotation of the servo. Here is a little delay if you, for example, need to feed your fish on a different interval for the first feeding, which I had to do. Here's the loop function, quite simple. First you store the number of milliseconds in the now variable, then you add the now variable to the fish feeder value, and you store that in the end time variable, and then you run your little while loop, which is basically says that if, as long as now, the now variable is smaller than the end time variable, the servo doesn't do anything. You can add a delay if you want, 1 second, 2 seconds, doesn't matter. It will loop as many times as it will, and then you update the now variable to the number of milliseconds that has passed since it executed the first time the loop, and so it will compare again, do nothing, and loop and loop and loop till it reaches an equality between the now and the end time variable. In that case, it will send println feeding time to the serial monitor, and it will execute, most importantly, the feed time function. And the feed time function is basically a function that doesn't return anything, hence the void feed time, and nothing in between the brackets. And it's 2 for loops basically, which are will turn in one direction and then back to the original position. So the for loop is basically position starts at 0. As long as the position is less than 180 degree, then we will increment 1 degree every time, and we turn 1 degree, delay 20 milliseconds, and then this until we reach 180. And then once we reach 180, then we will decrement -1 until the position is equal to 1, and when the position is equal to 1, we'll stop, and then we start again in the loop. And voila, that's the code. I hope it's clear for everyone. I hope you liked the video. I will see you next time, I hope. And if you liked it, don't forget to share, don't forget to subscribe, and don't forget to click the notification icon. And I will see you next time.